So, Oluchi, I'm going to start and put the recording on to introduce you. Yeah, good afternoon. Today is Monday, April 27. We have Oluchi Onwuvuche, senior graduating student that could not present last week, Wednesday, when we had the senior project presentation. So Oluchi has been rescheduled to present today, 4 p.m. And so we will start on the presentation. Oluchi, you can take over.
Okay. Good afternoon, everyone. My name, again, is Oluchi Onwuvuche. I'm an electrical engineering student. My project is on the ball and plate system. I was advised by Dr. Mahmoud, and my instructor is Dr. Esther Ososanya. First of all, I just want to make certain things clear, that the titles and the abstracts that were published and edited were not of my consent, and also that this project is self-sponsored. I honestly would like changes to be made, that this would be presented on the site. With that, I would like to begin my presentation. So in the USA, we use automation in almost every industry, whether it's aviation, the production of food, you name it. One example you can find this in aviation is auto throttling, in which the pilot gives the plane certain flight characteristics so that it could maintain or reduce the amount of fuel that's being consumed. In the production of food, of course, you can see that in how they wash, cleanse, and package their food for the market. This process is done by big machines, big machineries, but before they ever enter these industrial zones, they go through a number of tests. And these tests are really done with devices that are on a smaller level, but of a similar attribute. They have similar characteristics. So that is to see its quality and see if it's ready for an upscale and an introduction to the industrial sites or industry. In my project, I plan to do something similar to that, in which I would like to create a prototype in which it could be used in different industries. What I'm eyeing is more so of the exploration of different planets and different places in the universe. So my device is really designed to really analyze controls, algorithms. So what this system does, I named it the ball and plate, is that it, based off of a user's input, the system will try and navigate and direct an object, which is a ball bearing, to follow the instructions of the user. And this is done by using a controller called a PID. So what my project plans were to create algorithms that could that the system could follow and implement on the ball bearing. So the positions are the functions are position, circle, and ellipsis, infinity, and also manual. The manual mode is a different feature in which you use a peripheral called a joystick, in which you can navigate or tell the device to move the object in the desired path you want it to go. So the basic mode of operation is that we have user given an input. The input is being given to a controller, and the controller is then, based off of the user's input, translates it into a language in which the system, in my case, an actuator would understand, and afterwards perform it on the system, on the ball itself. And the feedback is more so of the resistive touch plate. And afterwards, this is now, the reference is now compared by the input, and the cycle continues. This is more so of a closed loop system. And I would like to repeat again that the controller that is being used here is a PID. So the algorithms for this PID is uploaded into a Arduino. And this Arduino that I'm using is the Ardunio Mega 2560. It's both a microprocessor and a microcontroller. And the clock speed of the Arduino is 62.5 nanoseconds. And I consider it to be a very powerful device for this project. This Arduino also can be powered by USB or a 9-volt jack, power jack. Okay, so for the PID itself, it's more so of using 3 components to control a whatever system you have. So basically, the first one is proportional, which is more so of the gain. Second, integral. So let me explain the proportional. Proportional more so deals with what's the event that's taking place in the now, the present. So basically, it multiplies the given error and gives it back to the actuator. So it receives an error, multiplies it by a certain value, and gives it to the actuator to perform. Now, the integral is more so of it's collecting more so of the past. Based off the analysis of the past, it receives the errors and it integrates it, and eventually it's given to the actuator. And for the derivative, it's more so of predicting. It's more so predicting the future. So it studies the behavior of the device, and based off that, it predicts that this is the likelihood of what the device would do. Now, how it analyzes this is by receiving the average value or the average position of the ball on the touch screen. And this is done in sampling time, so therefore it's more of a discrete type of analysis. That is why you have a diagram here that shows the description of this PID in the Z domain. Next, so for the touch screen in which it used to receive a feedback, how this works is more so if you want to measure the y-axis, if you want to measure the y-axis, you will have to bias the top 2 corners with a VCC, and you have to ground the bottom 2 corners with ground. So that is to measure the voltage difference of the Y. And then to measure the X, you have to, if you can see this, my mouse you have to bias the top left and the bottom left with a VCC, and you have to bias the top right and the bottom right with a ground. But this depends on how your system is, because your ground could be any type of voltage, but you just have to say, okay, in this range, this is what I mean for ground, and in this range, this is what I mean for VCC. In my case, VCC is 5 volts, and ground is simply close to 0 volts. So that's how I measured, and it's given an analog signal. So these 4 corners are each designated a wire, and a wire is also designated for receiving signals. To have a process in which you detect if an object is first placed on the touchscreen, you would have to bias one corner with VCC and the other 3 corners with ground. And once an object is placed on the touchscreen, it will send an interrupt. So it would give a 0 to the Arduino, and by that it will say, okay, there's an object on the touchscreen. So this is a if you can look at your left, you can see a table that really describes how the touchscreen works. And by the way, this device is the Elo Touch System, and to be specific, it's the E011881. And yeah. So so the next thing I want to present is the servo motors. This is the actuator in which this device is used to control the movement of the touchscreen. It receives a PWM, pulse width modulated signal from the Arduino. This directs it on the angle and the speed in which it's supposed to it's supposed to create. So if you can look at your right, you can see a graph in which it shows the mechanical positionings of the servo motor's arm. So the B1 is more so of the the location which the servo rotates. So I don't know if you can see my mouse. And then at the A1 is more so where the support rod touches the end of the servo arm. And then the PI, or because in this design there are 3 servo motors that are being used. So the I represents just the various servo motors I could be referring to. But the P position refers to where the rod interacts with the plate itself, or more so the interface that interface would connect to the plate itself. Okay. So in this project, an apparatus was designed, and this apparatus made use and considered the 3 servo motors with its support rods. And as I said before, that these the diagram on the graph that was shown before were illustrations on how the servo motors could be identified, and also characterized on how they were going to behave. But based off of my design and the calculations made by the Gibraltar formula, my apparatus is able to perform has the attributes of 3 degrees of freedom. That is that this apparatus can move in the X, the Y, and the Z domain. what this, and I have presented the formula. What this formula simply shows here is that the M in which the type of situation I'm dealing with. So I'm dealing more so not so much in the planar, but in the spindle, in which my device is in a location where it could act, that is move in the X, the Y, the Z, and also have a spindle attribute to it. That is, it can spin in the X, it can spin in the Y, and also in the Z. So it has a rotation component to it. So my device also has a likelihood of leaning towards having more than 3, but I considered that all my constraints were independent. That is more so dealing with an ideal case. So, and the reason for it being for it having 3 degrees of freedom is basically on how the bodies are connected to each other. So two things that stand out is how the servo motors are connected to the ground, and also how the supporting rods are connected to the interface. So the connections, the servo motors connected to the ground is considered as one as one joint connection, and then the connections made at the interface is considered as one because they all shared the same connection. So here is a description of the wiring of the device. So basically, I have a joystick which is connected to these 3 pins, A13, A14, A15, A13, A14, A15, and my LCD. One thing about my LCD, which I'll explain later, is that it's because of how it's designed and the type of interface, it's made easy. You only work with 2 channels, and that's pretty significant when you compare it to all the other type of similar devices out there. Touchscreen, as I said before, there are 4 wires designated to the 4 corners. That is the top left, the top right, bottom left. They have their own designated pins, and then the signal pin with the signal wire connected to a pin is also included. The Arduino, as I said before, can be powered by the USB. And for the servo motors, each of them are given their own pins. Yeah. And also, I just included a small fan just to reduce the overheating or the heating that might take place. So let me just explain. So here is the user interface. So what the user interface. So basically, these are the devices that the user would use to understand what is going on, or use to direct the device to do a certain function, you name it. So the LCD here is being used to display the menu. It's also used to select the function that you would like to, that the user would like the device to perform. And this is done in part with the joystick. The joystick helps the user to navigate through the menu and also make its selections. What I was trying to explain before is that the LCD is very interesting, in which it has 16 pins, in which if you go by just using that, it consumes a lot of space in your circuitry. And to reduce that, I purchased a combination of the LCD and the I2C. So the I2C helps the LCD interact with the Arduino. And basically, you just have one that is more of a serial control, and one that's just displays the instructions. So this is the reason why I chose it, because it was pretty more convenient. And also the Arduino has its pin, a certain pin that specifically says that it's SCL, and another one that is SDA. So for the testing of the ball and plate system, the system already would start by initializing to a specific position in which you tell it to actually try and position the ball itself to a position that you've already programmed it to fulfill. This is really done in the Arduino, where you try and type in the initial position. So that's more so of try and error and fine tuning. And since I mentioned fine tuning, while the device is still running, you can also tune the PID. That is, you can tune the gains of the proportional, of the integral, and the derivative. But the characteristics of the proportional, the integral, and the derivative will remain the same. It's just so much as you're changing the gain of each of these aspects of the controller. For the errors that are being received, like I mentioned before, it receives the average value of the position of the ball itself on the touchscreen, and based off of that, it gives those informations to the error formula. So there are 3 servo motors. The first one is more so of the leading one, and it being the leader, the other 2 will make its own calculations based off of the behavior of the servo motor, the servo motor 1. If you can look at your right, you can see the formulas that are given for each of the servo motors. So first one is simply the second value of the I1 minus the initial, and then you have the following as the servo 2, and then the next one is the servo 3, and these are divided up, like the description says, in like 120 degrees apart. The servo motors are mounted 120 degrees apart. So how does the servo motor behave? More so, it deals with timers. It deals with timers, and basically timers are in the Arduino. The Arduino that I'm using has a frequency of 16 megahertz. And if you're trying to look at the sampling time, is about 62 nanoseconds. So this is the fundamental sampling time that the device can have. And then based off of that, it's more so of the foundation for all the other the 3 servo motors. So each servo motors are going to be given a timer or a counter, and the timers are 16-bit. And the reason why they're 16-bit is because of just max value that it can. You're trying to see if you can have a device in which it has a quick response time, and also, you know, you can also fine tune it to say, okay, it doesn't really need to be that fast. So the options you can really have in choosing a timer, you can have one that is 8-bit or one that is 16-bit. And for the 16-bit, you have about 65,000 counts. Now, that's the max. But in certain cases, because of what the information from the PID says, sometimes you might need a duty cycle that is quite less than that is given. So how it works is that in my description here, it says that the OCR, in which it's a value in which you compute to say, okay, this is the duty cycle you want the servo motor to have. And so once the counter counts from 0 all the way to the OCR, it stops. And once it stops, it goes to the COMP, which is the compare match interrupt. Now, the compare match interrupt could be a 0 or whatever value you want it to be. So with that, it simply shows that, okay, this is how you create a duty cycle. This is how you create the on time of your servo motor. And also you create the sampling time as well. The sampling time as well. So this varies based off of the information received by the based off the information that the PID gives to the servo motors. So, and I would like to also say that depending on the duty ratio, the duty ratio actually depicts on what type of angle the servo motor should have. And then the sample time also depicts, okay, the speed in which the servo motor has to create that angle. Oh, sorry. So basically, the patterns that were created or are to be created are parametric equations. And on your right, you can see just a simple example here. We have the circle, in which they share the same amplitude, but when you have the ellipses, you can change it to your own convenience. So you have one that's 25, and then you have one that is 40. This depends on the user, but that's just my own version of ellipses and a circle. And then also have the manual mode, in which it simply looks at the user's input. So certain values would depict, okay, their joystick is moving upwards or downwards, left to right, and based off that, it gives that information. So it tells the Arduino that this is going to be your X, this is going to be your Y. So what you have to do is that you have to try and navigate. You have to try and tell the servo motor to try and arrive at these two coordinates. So that's how the manual mode works. So in the end, my project was designed to create or to perform functions such as the circle, the ellipses, the infinity, and the manual, based off the inputs from the touch screen. But at the end, it wasn't able to fulfill that, and for several reasons I'm not sure of. But what I do know is that some of the mechanical features could be upgraded, such as the joints that interacts with the servo arms. It seems to not evenly distribute the weight of the ball bearing and the touchscreen. So therefore, whenever you initially start the device, it would lean to a certain direction instead of a centered positioning. I would like to thank the administrators of the Cs and the EE department. Just a special thank you to you all. And with that, I open the project to questions.
Oluchi,
Yes.
you have a demo of the hardware that you recorded. Do you have the demo with you to show that
Yes,
before questions and answers?
Okay, I don't know if you can see this on your screen.
Not yet. Okay.
All right, are you able to see the video on the screen?
Not yet.
Okay.
Okay.
Okay. This is a 20-minute video showing you the circuitry, how it's wired. Also, it's going to briefly show how the menu works and some of the features of the on the menu. So like I said before, mechanical changes need to be made. This is more so of the prototype of this project. It's made out of cardboard, but it's pretty decent. It really depends on the servo arms and its interaction with the servo. So it's the interaction between the servo arm and the supporting rods. So probably what could change for the joints is a clevis so that it can make it more sturdy or more strong. Like I said before, you can power the Ardunio with a USB cord. So this is just what I'm doing here. Okay, it starts with welcome menu and then the main menu. The welcome menu is in the setup, so it only shows once for about 250 microseconds. Here, like I said, you can navigate with your joystick. The up and down are programmed in the Arduino to look at a certain voltage range, and based on the voltage range, it will make that type of movement. So it'll move up, down, based on the voltage range. Here I'm just navigating through the different functions. I made an attempt to select, but it did not respond. This is my trial and error type of phase. And also, like I said before, you can try and look at your gains for the PID. Also, there are other features. I try to put a computation feature, trying to see how fast it can work. Also, looking at the pattern directions, the forward, reverse or forward, and like the speed in which it's actually performing your the function. So that's more so of the showing the menu. And then let me see. I have another video that shows my attempt to start the program to fulfill a function. I don't know if you can see the video.
Yes.
Okay. This is it. This is me trying to see if it could go to the center position. Like I said, I didn't really get what I wanted it to do, but it is following a direction. It's saying that, okay, I'm trying to place the ball at this location. Now, like in your computer science class, the only thing that the Arduino sees are ones and zeros, and it's up to the programmer to say, okay, this is what I mean. So if you're saying that this is 1 and 0, okay. Now based off that, okay, I actually want you to be at let's say 50 millimeters in the X direction and 60 millimeters in the Y direction. And I have to translate that to the computer. So what I've been really dealing with is more of a trial and error, trying to see if both me and the device can understand each other. That's one way to put it. So this is what I was able to accomplish. Any questions?
Was the Arduino able to read the position of the ball? Was the Arduino getting the touch screen output at any? Did you see that it was getting the touch screen output?
Oh yes, it did. Like I had two ways of reading that. I could read that through the serial monitor, or I could read it through the menu itself. I had a problem in which I wasn't able to do both at the same time. I think it was more of the computation and how I organized my program. It had to fulfill a certain task before it could complete the next one. So yes, I was able to. The question is, was I able to read the positioning of a ball bearing on the touchscreen? And yes, I was able to do that.
Yeah, maybe you could have partitioned your code into smaller steps that you take that value and just program the derivative or the proportional to get that to work first. See how that code is running, do single step on that code to get familiar.
That's probably a step I should have taken, yes.
Yes, step by step does help.
Hello, can you hear me?
Yes.
Yeah, I looked at if I googled Poland plate, and there are so many projects for that is working, and there are a lot of demos on the Google showing how the system works, and actually some of them are showing the code. All of them also are using the Arduino system and using a touch screen and using the joystick and everything like what you are doing. And did you have a chance to look at them?
The ones I saw were more of the X using 2 servo motors. And so that seemed to be really simplified, because basically you can say, okay, whatever measurements I'm receiving from the touchscreen, from the X, this servo motor fulfill this,
No,
trying.
actually it was X and Y because they have the elliptic, they have the manual, they had the
Yes,
up
yes,
and down.
exactly. Yes, exactly. So in all those cases, you have the X and Y, which are touchscreen. But in my case, I had 3 servo motors, and so you cannot simply designate one servo motor to an X and then another one to a Y. What about the third one? In the video clips that we're seeing, I was seeing that they were designating the measurements from the touchscreen that is X to one servo motor, and the measurements from the Y to another servo motor. So that is, they're using 2. And then they try and support that with a centerpiece. Now, in my case, I try to use 3 servo motors in which it supports the platform, and also it's supposed to take in information from the Arduino based off the X and the Y measurements it receives from the touchscreen. So it seems helpful, yeah.
But if you are trying to do much more than and it doesn't work, then I am not sure such a big project can be done by only one person. Senior projects are supposed to be a teamwork. That's what.
Yeah, that's exactly, yeah. I didn't plan to really work on my own. When I first came into the senior year, I did introduce my project to other members of the senior class, and they had their own interests. And I just understood that that's okay, and I simply said that I'll venture off and try and do this on my own. So yeah, I do understand that this should be a teamwork.
You see, when we present this stuff to ABIT requires teams, not just one person. So I am not sure. And at the end, it didn't work as you said.
Yeah.
Okay.
Any more questions for Oluchi? Yeah, Oluchi, you may need to outline future work, the challenges that you faced, and future work recommendation.
Yeah.
About that.
One other thing I'd like to point out, I was looking at his report, and description of the component used are mixed with the work done. Excuse me. I wish that he would have some section which describe the tools and software, then another section which describe the work done. Because I will see why he starts to talk about algorithm, then he goes back and describe say his joystick or the Arduino or this the tool that he was using. So I hope that he reorganize his report, which is starting to say why he is doing such a project, then what are the tools and software are used, then what is being done and how it is tested, or what will be the shortcomings, and then some the lessons learned or ideas for further work. The report, as I saw it, it is mixing everything together.
Well, yeah, you need to comment that in the report so students could carry out the corrections on that.
I mean, the tools should be in a separate section.
I think it's hard you. You did hear what Dr. Mahmoud said to you, Oluchi?
Yeah.
Yeah.
Yeah, you need to organize it. Something start by why this is important, why you want to do it, then something about the algorithm, etc. So another section which has all your tools, the hardware and software. Another section which said what is this project, how it is done. If they're successful, there will be a testing one, but if not, then maybe something which says what did you learn and what will be the uh, 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 future correction or future addition to this project.
Okay.
And of course, you have all the code will be the appendices, there, like you did.
Yeah, and codes to be well documented here.
And one other thing I have seen, and I think you need to fix that, there's no references at all.
There is a reference.
Maybe, but while you are writing, you did not say reference 1, reference 2, reference 3. So while I was reading, I may not have seen that.
Okay.
You may have put some reference at the end, but you have to relate the writing to the references.
You're encouraged to use IEEE format on Look on Blackboard website. The video on IEEE format of references is posted. We did that in class maybe 2-3 weeks ago. There's a video posted on it. Try and organize your work with a table of contents. There is a video posted on how to organize work using table of contents also. That was covered in class about 3 weeks ago also. So on the report, we will look at what you submitted and we'll give you corrections on what you have to do to complete your report.
Okay.
Any more questions for the presenter from the audience? Is Dr. Carol from IEEE? I believe she was on earlier. Dr. Carol?
I don't see her in here.
Oh, okay. Brihema?
I think he left also.
All right. Any question for Oluchi?
Oh, no. The only thing mentioned is what Mahmoud said. This work should be like a group of work because it's a list to work on.
Yeah, needs to work on the report.
Yeah. It should be easier, like if you was working with somebody else. So
yeah, you need to list the challenges.
Yeah, he did good job.
Yeah, the challenges you will list and link it to future work. Recommendation for future work. Okay, that ends the presentation. We will be working with the student on the report. I'm not sure if you will be able to do corrections on your report between now and tomorrow when the senior grades are due, but you do have the contract form for in-progress work in case you're not able to do correction for a few days. Then your grade will be submitted once we have your corrections done. Okay, Oluchi, complete the contract form for work in progress. The reason being that you need to do corrections on your senior project report and resubmit. So that may be completed during the week. That's up to you. In progress does not mean student lacks or fail. It's just that your grade will not be ready for tomorrow. IP is what will be shown there tomorrow. All right, thank you very much, everybody. That completes our senior project presentation. Bye.